Good morning and welcome to class today. Today we are going to be learning about linear inequalities in one variable. In the course of the class today, we are going to understand what inequalities mean. We are going to understand what linear inequalities mean in mathematics. We are going to learn the rules for resolving linear inequalities. We are going to learn to represent linear inequalities on a number line. And of course, we are going to solve mathematical problems relating to linear inequalities. So what is an inequality? As the name suggests, an inequality is simply a term used to suggest that two quantities are not equal. That is the opposite of equations. While equations tell us that two quantities are equal, inequalities tell us that two quantities are not equal. So an example will be two classes. We have our year 11 and our year 12. We know that there are not the same number of students in the classes. So if you are going to represent them mathematically, you'll be saying the number of students in year 11 is not equal to the number of students in year 12. So having a plate of rice and beans, for example, when you cook your rice and beans, you know that there will always be more grains of rice in the plate than beans. So a linear inequality, another example of that is going to be saying that there are more grains of rice than there are of beans, or there are less grains of beans than there are of rice, or there is a larger, or the quantity of rice and beans are not equal. Those are examples of inequalities. Inequality in mathematics is represented with the following signs. We have this sign, the sign of equal to, with a line striking through it. This is called the not equal to sign. This, of course, means less than or equal to. This means greater than or equal to. This means less than, and this is greater than. The difference between this sign and this sign means that in this, it could be equal, but in this, it can definitely not be equal. For example, if you want to count the number of students in a particular class at every point in time, we know that at a particular point in time, the number of students in the class can be 0 when no students are in the school. So, if we want to measure the number of students present in a class at any point in time, we are more likely going to be using this sign or this sign because there is a possibility that they will be equal at certain points. However, if there is no possibility of them ever being equal, then we use these two signs. Now that we've understood what inequality means, what are linear inequalities? In my introduction, I mentioned that inequalities are related to equations. And we all know that a linear equation is an equation where the highest power of the variable is 1. Similarly, a linear inequality means an inequality or an algebraic inequality where the highest power of the variable is also 1. And this is an example, having 2x minus 4 less than or equal to 3. This is a mathematical statement of inequality in one variable. If we had x and y, then to be a statement of inequality in two variables. If we had x squared, then it will no longer be a linear inequality, but a quadratic inequality. The rules for resolving inequalities. For resolving inequalities, we just need to remember that inequalities are very similar to equations. Every rule that applies to equations applies to inequality. However, there is one rule that applies to inequality which does not apply to equations, and that is only possible because in inequalities we have directions. So let's go into it. These rules, the first and second rules, simply tell us that if we have any number less than another number, if we add the same thing, any constant number c, which is not negative, a plus c will remain less than b plus c, or a plus c will remain less than b plus c if we add a constant number. For example, if A was to be 7 and B was to be 9, adding the number 2 to this will make A 9 and B 11. So A will still remain less than B. And that holds true for this. Same thing happens if we are multiplying, except that when we are multiplying, our constant cannot be 0. If A was to be 7 and B was to be 9, and we have to multiply both of them by 3, for example, 3 times 7 will give us 21, and 3 times 9 will give us 27, so it will still remain less than, as long as the number is not 0. If it was 0, then multiplying this by 0 will make it 0, and multiplying B by 0 will make it 0, which makes them equal, and the sign will no longer hold true. So this is what the first 4 rules tell us. We can add the same number to both sides or divide both sides by the same number. As long as it is positive, our sign remains the same and our inequality remains true. However, the last rule tells us what happens if we are dealing with a negative number. When we divide by a negative number, the sign gets inverted. Because we all know that 1 is less than 2. However, minus 1 is greater than minus 2. So if you divide or multiply an inequality by a negative number, then you'll have to invert the sign. Now, let's have an example. Here we have the example 2x minus 4. 2x minus 4 less than or equal to 3. To resolve this inequality, how do we go about it? If this was a simple equation, what will you do? Of course, you use your board math, solving it in reverse. You will need to eliminate this minus 4, and to do that, you will add 4 to both sides. Since we are adding a constant term to both sides, applying our first rule, this is going to give us 2x minus 4 plus 4 less than or equal to 3 plus 4. And that's going to give us 2x less than 7. To solve this, the next thing we do is divide both sides by 2. Since 2 is a positive number and it's not 0, this sign will also not change, and we can easily divide 2x by 2 to get x and divide 7 by 2 to get 3.5. And this is how we resolve inequalities. Let's look at another example. Here we have 5 minus 2x less than 1. To resolve this inequality, we do the same thing. We subtract 5 from both sides to get 2x less than minus 4. And after that, what do we do next? Of course, we need to divide by the coefficient of x. That means dividing both sides by minus 2. Since we are dividing by a negative number, the sign changes in this last line. Rather than being 2x less than minus 4, we end up with x greater than 2. And that is how we resolve inequalities. Inequalities in one variable can be represented on a number line after they have been resolved. In our last example, we had x greater than 2. When you have resolved an inequality that way, you can represent it graphically on a number line. To represent inequality on a number line, first we draw a cycle over the reference number. In the case of the last example, that would be 2. And you have to draw an arrow from the cycle in the direction of the inequality. So if your cycle is on 2 and your sign is less than, you will draw an arrow facing the left, that's towards 0, 1, minus 1, minus 2. But if you are dealing with greater than, your arrow is going to be pointing towards the right, that is towards 3, 4, 5, the numbers that are greater than that number 2. You shade your cycles if your number is included. That's when you are using these signs. The cycle should be shaded, but the cycle should not be shaded when you are using these signs. This is an example of how a number line is drawn. You can see x less than 4. Our cycle, unshaded cycle, is over 4, and because the sign is less than, our arrow points in this direction. The arrow always points in the direction of the inequality. And here we have x greater than or equal to minus 2. So our cycle is over minus 2 and is shaded because our sign is less than or equal to. And the arrow being greater than or equal to, and the arrow is pointing towards the numbers greater than minus 2. I hope you're able to learn something new today. Here are some practice exercises. You are going to solve them and upload in Google Classroom. I'll be grading you there and answering your questions. Here we have 8x minus 2 less than or equal to 9x. We have 2x plus 1 less than x plus 5. We have 3x minus 5 less than 5x minus 3. And here we have 2x plus 6 less than 5 into x minus 3. So solve them and ask your questions. See you in class.